exercise 1.2 on equating coefficients and 1.3 on our polynomial division. We're focusing on the idea, of course, in 1.2 that we already know how to work with quadratics, graphing, etc. Right? But in this case, we're focusing purely on the algebraic aspect. The name is very intuitive. Equating coefficients. If two polynomials expressions are equal, then we can equate the coefficients, so the numbers, and sometimes in our case the pronumerals in front of our variables, of each corresponding term on either side of the equal sign. Let's let p of x equal to 4x cubed plus 3x squared minus 2x plus m, and qx equal to 5x cubed plus 5x squared minus 2x plus n. First thing I want you to do is I want you to cross this out and replace that with 2. That is a typo on my end. Great. Alright, so for this question, of course, it says show that, which means that we can't just put numbers into the equation we've got, right? The number one mistake students make with show that is it would say show that this equals to that, and they'll just, for example, grab this and substitute something into that to try and get an answer. Show that means you must be able to do it without using what they've just provided in that show that question. So instead, we have to use this information up here. We'll address that later on when we look at exam questions anyway. So 4x cubed, of course, we're looking at 3px. 3px, of course, is going to end up equaling to 12x cubed plus 9x squared minus 6x plus 3m. Pretty straightforward. And of course, our 3m. And of course, our q, which becomes 2qx, is just going to end up equaling to 10x cubed, plus 2mx squared minus 4x plus 2n. You can see where my typo error came in. Okay, and to show that, we just have to add them together. So 3p of x equals to plus 2qx equals, and I'm just going to add them together. So that's 22x cubed. Now here, what you might do is to separate them out, but I'm going to skip a step. Instead of writing plus 9x squared plus 2mx squared, I'm just going to go ahead and write plus bracket 9 plus 2mx squared. Any questions about that step I've just skipped? Okay. So we continue. Minus now becomes 10x, and then plus 3m plus 2n. Et voila. Great. Now, the equating coefficients component comes in part B. It says if 3px plus 2qx equals to that function as provided, find the values of m and n for x is an element of all real values. Of course, this component here, let me get my highlighter out, this component here, 2x cubed and 5x squared, 2x cubed is pretty straightforward, obviously, and the negative 10x is also pretty straightforward. It's the same coefficients. The different coefficients are 9 plus 2m, which would equate to our positive 5, and our plus 3m plus 2n, which would equal to plus 6. Do note that despite the fact it is a pronumeral, in our case, because it's a function in terms of x, m and n are constants. They're just a number. It's not a changing number, it's a number. Okay, so let's focus on the first one. It's pretty straightforward. We know that these two equate, and we know that those two equate as well. So 9 plus 2m equals to 5, which of course gives us m equals to negative 2. The next one we're equating would be 3m plus 2n equals to 6. Again, because I'm equating the constants in both cases. And we end up with, well, we've got two variables. We can actually substitute this one in. We end up with negative 6 plus 2n equals to 6, therefore n equals to 6. Does it seem pretty straightforward how we can equate the coefficients? Yeah. So equating the values in front of the x, sometimes you end up with, of course, brackets, in which case you equate those as well. And of course the constants you can equate as well. There are only a couple of exercise questions for this topic, so we should be able to move on swiftly from this one. Great, once you're ready, let's turn the page. Let's move on to our polynomial division. Ooh, that was your favorite topic last year, wasn't it? Yeah? The excitement on your faces, it's glowing. Alright, polynomial division. It's very similar to normal numeric division. Of course, we're using long division, because if you can do this in shorthand, I'll be quite impressed. Okay, so of course, the idea is we're factorizing. That's what division is. We're dividing something. We're factorizing with sometimes remainder to spare. All right, let's start with long division with a monic divisor, with just a basic quadratic divided by a linear. Okay, the process is as follows. Of course, it's a long division, so I'm going to write x squared. I'm going to zoom in a bit so you can see. X squared plus 7x plus 11, sorry, divided by, and I like to just put brackets in so I don't forget that, x plus 2. My divisor is x plus 2. Okay, how much detail would you like me to go into for this? 1 to 3. You can just put 1, 2, 3. Okay, on average we'll go with 2 then. Alright, so I need to think, what value do I multiply x plus 2, or let's focus on the first term actually, x by, in order to get x squared? Of course, I have to multiply x by x to get x squared, so I multiply that by x. I multiply everything in my divisor by x, so x squared plus 2x. I've just multiplied x by x and 2x by 2x. Sorry, 2 by 2x. 2 by x, my apologies. The thing that a lot of students forget, make sure to include a negative in the front, minus. A lot of students don't write that and forget. It's not to say that you lose marks if you don't write the minus, but a lot of students misunderstand, especially if you've got a negative term in the second section. They can apply that incorrectly, so I just put that in to make it easier. 7 minus 2x gives me 5x. Of course, every time you do this, this section should always be a 0. I bring the 11 down. So that becomes plus 11. I think what number multiplies by x to get 5x? Of course, in this case, it's just going to be positive 5. Right? And that gives me 5x. And of course, I multiply the 2 by the 5 as well, so that becomes plus 11. Again, I'm going to apply my negative up the front. That gives me a remainder of 1. Okay? Now, how do we write this out?
10.
Remainder of 1. Thank you very much. Okay, thank you very much. Okay, so now how do we write this out, right? If we're dividing this function by that linear function, we can write it out as, and if I'm writing this in long term, yeah, you can write it out as x squared plus 7x plus 11 over x plus 2 equals, now what do we get? Of course, we got the x plus 5. I'm just writing that in brackets for my sake. Plus, and the remainder is 1, but we don't just write 1, because it's not plus 1, it's plus 1. That would still need to be divided by x plus 2. So it'd be plus 1 over x plus 2. If you were to rewrite it, let's say the question wasn't to divide it, but to factorize it. You don't have to write this part down, but you can if you'd like. If you were to factorize it, then you would end up with x squared plus 7x plus 11 equals x plus 5, that'll be from above, multiplied by our divisor, x plus 2, plus 1. In that case, your remainder would be just that number there. Okay? You might notice it's just multiplying both sides by x plus 2 anyway. Exactly the same thing. Okay. Would we like me to go through an example where the coefficient of the divisor is not 1?
Yes.
Yeah, thank you for being very, very quick about that. Okay, so in this case, it's going to get very ugly. Okay, we're going to end up with fractions. So I'm going to go through this quickly. I'm just going to hope that you trust me with my fraction work. Okay, so 3x cubed plus blah, blah, blah. We're just going to rewrite that as per usual. 3x cubed plus 2x squared minus x plus 2 divided by our 2x minus 1. Same thing as per usual. What number multiplies by 2 to get 3? That can get very confusing. The way I think about it, in order to get from 2x to 3, I'd have to divide it by 2 and times it by 3. So divided by 2 times it by 3. So 3 over 2. Of course, it's 3 over 2 x squared. We're trying to get to x cubed. From x squared. I multiply everything in that bracket on the left-hand side by 3 over 2x squared. That becomes 3x cubed, sorry, plus 3 over 2. that should be a minus, my apologies, minus 3 over 2 x squared. Any questions, qualms, queries? Question? No? Okay. Alright, so let's put a negative on the front just to make our life easier. Of course, that cancels out to be 0. On the right hand side, we end up with 2 plus 3 over 2. 2 plus 3 over 2 gives me 7 over 2 x squared. Sometimes for me, right, when I'm working through this, I'm like, that fraction's really annoying. I'll just write on the corner 2 plus 3 over 2 and then just solve blah, 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 do the coefficient, bring it back in. You don't have to do it all in your brain. Okay, let's keep going. I bring the negative x down. And I think to myself, what number do I have to multiply 2x by to get 7 over 2x? Of course, it's divided by 2 times it by 7 over 2. So that becomes positive 7 over 4x. Of course, on the bottom, I multiply, that becomes 7 over 2x squared minus 7 over 4x. I subtract them, and I end up with negative 1, essentially. Negative 1 plus 7 over 4, which gives me 3 over 4x. At this stage, we're either feeling really big brain or really small brain. Please let me know afterwards. I've already brought the negative x down. I'm just bringing down the positive 2 now. So bring the positive 2. What number do I have to multiply 2 by to get 3 over 4? It's just going to be 3 over 8. In other words, divided by 2 times 3/4, 3 over 8. That gives me 3 over 4x minus 3 over 8. I'll be subtracting that, of course. There we go. And we end up with 2 plus 3 over 8, which ends up being 19 over 8. Oh, that is gross. Okay, let's write our answer out. If we're dividing this function by our linear equation, I can rewrite that as equals to, right, because we're dividing, we end up with 3 over 2x squared plus 7 over 4x plus 3 over 8, that's just my quotient, plus, and we're going to end up with a remainder divided by our divisor, which is, and don't write this part out because I'm just going to erase it in a second, which is our remainder of 19 over 8 divided by 2x minus 1, right, which is annoying, so let's just rewrite that as 19 over 8 times 2x minus 1. Tricky, but did that feel achievable? Lovely. It's the fraction work that gets most people in this case. You're welcome to write on the side. Your examiner won't take off marks if it's fine, right? The coefficients are the annoying part. Okay, let's move on. Last page. Synthetic division. Did you do synthetic division last year? A little. It's an optional thing. You will never be asked to do synthetic division. The only thing is, the reason why it's not a compulsory concept is because it's very limited by the fact that it is only when dividing by a linear factor. Only applicable when dividing by a linear factor. So, for example, if it's dividing by 2x squared, you can't use this. I'm going to walk you through the process, right? It is admittedly, like I wish I used this in high school, but admittedly it is a lot easier, but it just means you have to learn something else. Up to you. You don't have to use this. No one's going to ask you to absolutely use synthetic division. Okay, so let's let p of x equal to 3x cubed minus 8x squared plus f of x minus 1 and dx equals to x minus 2. Right, we're simplifying. Again, note it's a linear equation that we're dividing by. The divisor is linear, therefore this applies. So what we're going to do is the same thing that we're going to look at for factor and remainder theorem. Let equals 0, solve for x, you end up with x equals to 2, and you essentially write 2 on the left-hand side. You write whatever they would equal to on the left-hand side. And then you just write the coefficients of whatever you have. So in this case, it would be 3, negative 8, positive 7, and negative 1. Those are the numbers here. So your divisor, coefficients of your dividend. Okay? Then you just follow this pattern. You say, okay, well, you've got 2, 3 here. I'm going to bring the 3 down, and then I go 2 times 3 is 6, and then I calculate this. Negative 8 plus 6, that's negative 2. And you'll notice the pattern, and I'll show you what I mean. The pattern goes like this. Okay? So up next, negative 2. So we're going to go 2 times negative 2, which gives me negative 4. And again, I just work down. 7 minus 4, 3. And then I go 2 times 3 is 6. And then I work down the page. That's just positive 5. I'm going to do that one more time very quickly. I look down the page. It's a 3. Right? And then I go 2 times 3. It gives me 6. And then I go work down the page. That's negative 2, sorry. And then I multiply. 2 times negative 2 gives me negative 4. I work down the page again, 3. 2 times 3, work down the multiply that, gives me 6. Work down the page again, 5. Once you end up with these values, that's all you need. Because we know the first one is going to represent in a coefficient x cubed. When we divide it by a linear factor, of course, it's going to be x squared. So therefore, our 3 represents a coefficient of our x squared. Our negative 2 represents the coefficient of our x. The 3 represents the coefficient of our constant. And the 5 represents the remainder. Again, only works for linear equations. Totally optional. You don't have to do this. Okay? Any questions? Okay.